Imagine the universe moments after its birth. A time when everything we know was condensed into an incredibly hot and dense point, a singularity. This was the beginning of everything, the dawn of time and space itself. The Big Bang's energy crackles, a chaotic soup of particles colliding at unimaginable speeds. This explosion set the stage for the universe's expansion, creating a seething, roiling mass of energy and matter. In this extreme environment, some physicists believe defects arose in the very fabric of spacetime, like cracks in newly formed ice. These defects are not just random occurrences but are thought to be fundamental features of the universe. These hypothetical defects, known as cosmic strings, are thought to be incredibly thin, perhaps thinner than a proton, yet stretching across vast distances, potentially even spanning the entire observable universe. Imagine a thread so fine yet so long that it could weave through the entire cosmos. These are not the strings of string theory, which operate on a much smaller scale. Cosmic strings are a different concept entirely, existing on a scale that boggles the mind. Cosmic strings, if they exist, are remnants of the universe's earliest moments, wrinkles in the fabric of spacetime itself. They are like scars left over from the universe's violent birth, holding clues to its most profound secrets. Their existence, while still theoretical, is a captivating possibility that could reshape our understanding of the cosmos and perhaps even unlock the secrets of time travel. The idea that these strings could influence the flow of time is both thrilling and perplexing. The search for cosmic strings is a testament to our insatiable curiosity about the universe. Astronomers and physicists alike are driven by the desire to uncover these elusive threads, scanning the night sky for any hint of their presence. It reflects our desire to understand the most fundamental laws of physics and to unravel the mysteries of our cosmic origins. The quest to find cosmic strings is more than just a scientific endeavor, it's a journey to understand our place in the universe. The possibility, however remote, that these cosmic threads hold the key to time travel adds an extra layer of intrigue to this already fascinating area of research. If proven true, it could revolutionize our understanding of time and space, opening doors to possibilities we can only dream of. One of the most mind-boggling aspects of cosmic strings is their predicted density. Imagine compressing the mass of Mount Everest into something smaller than an atom. That's the kind of extreme density we're talking about with cosmic strings. This incredible density arises from the way cosmic strings are thought to have formed as defects in the very structure of spacetime itself. Despite their immense density, cosmic strings would be incredibly difficult to detect. Their thinness, combined with their vast distances from Earth, makes them frustratingly elusive for even our most powerful telescopes. However, their extreme density means they would have a profound effect on the space around them, warping the fabric of spacetime in a manner unlike anything else in the universe. This warping of spacetime, a consequence of Einstein's theory of general relativity, is key to understanding how cosmic strings might enable time travel. Their immense gravitational pull could, in theory, be harnessed to create shortcuts through spacetime, allowing us to journey through time as well as space. Albert Einstein's general theory of relativity revolutionized our understanding of gravity. Before Einstein, gravity was thought to be a force acting at a distance as described by Isaac Newton. However, Einstein's theory introduced a radical new concept. It tells us that gravity is not a force acting at a distance but rather a curvature of space-time caused by mass and energy. This means that massive objects like stars and planets warp the very fabric of the universe around them. Imagine a bowling ball placed on a trampoline, causing the fabric to sag. Smaller objects placed on the trampoline will naturally roll towards the bowling ball, not because they are being pulled by a force, but because the fabric is curved. This is a simple analogy for how massive objects warp the fabric of spacetime around them. The more massive the object, the greater the curvature, and thus, the stronger the gravitational effect. Cosmic strings, with their immense density, would create even more extreme distortions in spacetime. These hypothetical one-dimensional defects in the fabric of the universe could stretch across vast distances. Instead of a gentle sag, imagine a deep, narrow well running along the length of the string. This well would be incredibly steep, creating a dramatic effect on the surrounding spacetime. This well would not only affect objects moving near the string but could also create unusual pathways through spacetime, potentially allowing for time travel. The intense gravitational fields could bend space-time in such a way that closed time-like curves, or loops in time, might be possible. This warping of space-time is not merely a theoretical curiosity, it has been observed and confirmed in various ways. Scientists have detected gravitational waves, ripples in space-time caused by massive cosmic events, which further validate Einstein's predictions. For example, the bending of starlight around massive objects, a phenomenon known as gravitational lensing, provides direct evidence for the curvature of space-time predicted by Einstein's theory. This effect allows us to observe distant galaxies and stars that would otherwise be hidden from view. If cosmic strings exist, their extreme density would create even more dramatic lensing effects, potentially offering a way to detect them. These cosmic phenomena could open new windows into understanding the fundamental nature of our universe. In the 1990s, physicist J. Richard Gott proposed a fascinating idea. What if we could use the space-time warping abilities of cosmic strings to create closed time-like curves, loops in space-time that could enable time travel? These cosmic strings, hypothetical one-dimensional defects in the fabric of space-time, are thought to be incredibly dense and possess immense gravitational pull. Gott's idea relies on the fact that near a cosmic string, space-time is so warped that it's possible for an object to travel in a loop and arrive back at its starting point in both space and time. This warping effect is due to the immense gravitational forces exerted by the cosmic string. Imagine two cosmic strings passing each other at high speed. The interaction between their gravitational fields could create a unique and extreme warping of space-time. The combined gravitational effects of these strings could potentially warp space-time so severely that a closed, time-like curve would form. This curve would essentially be a loop in time, allowing for the possibility of time travel. A spaceship traveling along this curve could in theory travel back in time, arriving at a point in space-time before it even left. This concept, while mind-bending, is grounded in the principles of general relativity. While this idea sounds like something out of science fiction, it is based on the established laws of physics as we understand them. The mathematics behind it is sound, but the practical implementation is another story. Of course, there are many practical challenges to overcome before we could even dream of building a time machine based on Gott's idea. The energy requirements alone would be astronomical, and we have yet to even confirm the existence of cosmic strings. Nonetheless, the concept opens up fascinating possibilities for the future of time travel and our understanding of the universe.